So let's see an experiment with respect to node voltage analysis. So the aim of the experiment is to determine the currents Ix, Iy, Iz and power associated with any two elements by applying node voltage analysis. We can see here we have a voltage source of both dependent and independent. So this is your 12 volt independent and this is 2 Iy which is dependent. So this is an voltage source, as you can see the polarity mentioned. It depends upon the current Iy which is flowing through 4 ohms in downwards direction. So let's see how do we solve this. So theoretical calculations. So this is your circuit diagram. So as you can see, we have already assumed the ground at the bottom and the other 3 junctions are assumed at higher potential. Let us name them as V1, V2 and V3. So is this a node problem or is this a super node problem? So pause the video and analyze, is this a node or super node problem? Now, assuming that you have selected your options, this is actually a super node problem. So the unknowns by nodal analysis or the unknowns by super node are, right, V1, V2 and V3. So we have 3 unknowns, we need 3 equations to solve for. So where are the 3, from where do we get these 3 equations? And in all the 3 equations, we'll have 3 variables V1, V2 and V3. So first let us write the constraint equation for super node. So the constraint equation with respect to 12 volt. So V1, 12 volt is equal to V1 minus V3 and we have one more super node, right, V1 and V2, that is 2 Iy is equal to V1 minus V2. Now you can see I have done that as equation A and we have not written that as equation 2 because as discussed we have 3 variables V1, V2, V3. We do not need a 4th unknown variable Iy. So we have to somehow relate Iy to V1, V2, V3. So how can I rewrite Iy as? So you can see here in the given diagram Iy is actually current flowing through 4 ohms. So how can I incorporate Iy with respect to current flowing through 4 ohms? So we can write the equation as V3 by 4. Substitute that V3 by 4 and you get your second equation, that is V1 minus V2 minus V3 by 2 is equal to 0. Now as discussed we need 3 equations, we already got 2 equations, we need to get one more equation. So now we have to apply super node to get your third equation. So how do we apply super node? Pause the video, analyze, and then once you have got your answers you can resume and check your answers. So to apply super node, one has to remove all the elements between super nodes. So which all are super nodes here? So super nodes are V1, V2 and V3. So which all elements are there between V1 and V2? So between V1 and V2 we have 2 Iy, remove that. Between V2 and V3, again these two are also super node, although they do not become super node explicitly, but still V2 and V3 are also part of super node by themselves. Thus you have to remove 2 ohms also. And 12 volt also you must remove because they are 12 volt appears between V1 and V3. So these are the 3 elements that one has to remove to apply super node equation. Now from this the equation is simple, V1 by 4, V2 by 1 plus V3 by 4. That's your third equation. So once you solve for equation 1, 2 and 3, you will get your answers for V1, V2 and V3 respectively. So I'm getting the answer as minus 3, 4.5 and minus 15 volt. Right. So now let us also find the currents which are asked, Ix, Iy and Iz. So what is the equation for Ix, what is the equation for Iy and what is the equation for Iz? So pause the video, write down and then you can resume and check your answers. The equation for Ix is current through 4 given as V1 by 4 and the answer is minus 7.5 amperes. And the equation for Iy as we written earlier, it is V3 by 4 and the answer is minus 3.75 amperes. And the equation for Iz is V2 minus V3 all divided by 2 and the answer is 9.75 amperes. So these are your answers for current Ix, Iy, Iz that we have determined by node voltage analysis. The second part of the question, as you can see, is power associated with any 2 element. So let's do for 3 elements here rather than 2, just to compare your answers or analyze for power associated with your passive elements and active element. So these 2 are the active elements. We have to find out the power and then comment whether they are active or passive element. And this is obvious that it's a resistance and it has to be passive. So let's start with 2 ohms first. So power with respect to 2 ohms. Right, so as discussed in your regular classes, to find the power, it's always suitable to use I square R. So which current is flowing through 2 ohms? It is Iz as shown in the circuit. So Iz square into R. Our value of R is 2, and we have earlier to this we have found out the current Iz, that is 9.75 square into 2. You get the power as 190.125 watts. This formula is very useful. This formula is the best to find power associated with passive elements. Now let's move on to the second one, that is with respect to 12 volt. Now how do you find power associated with 12 volt? We use the formula as it is in, we have to find out whether it's an active or passive. So we use the formula with respect to voltage source, V into I. Right, 12 into I. But is this formula correct? Now I have written as I, but you have to assume the orientation of current. So let us assume the current in the orientation as shown here. I am just assuming the current. Now this current, is it hitting negative of 12 volt or positive of 12 volt? As it's clear, it is hitting negative of 12 volt. Thus we rewrite the formula as 12 bracket negative sign, then the current I. Now how can we find the value of I by node voltage analysis? So we cannot do it by nodal directly. We have to use the concept of KCL. So let's apply KCL at V3. So when we apply KCL at V3, there are 3 currents, I, Iz and Iy. So how does one incorporate Iz, I and Iy by KCL? So we can write the equation as Iz is equal to Iy plus I. These are the orientations. Now we have already calculated the value of Iz and Iy, thus it's very easy to find the value of I as 13.5. So once you substitute the value of I, we get the answer as minus 162 watt. So this negative sign indicates that this is actually an active element. It is actually a source. So as discussed in module 1, whenever you see a negative connotation with respect to the power, that actually is dissipating. It actually is supplying energy, not absorbing. So you can see for R, right, we got positive answer because that is actually dissipating or absorbing. But here it is delivering energy. So 12 volt is actually your active element by seeing that negative sign. Now similarly with respect to 2Iy, I have already assumed the rotation of current in towards positive of 2I. I have written it as I1, right? And we know the value of Iy we have already calculated. Thus when I multiply that, I get the answer as minus 7.5 volt. Okay, so I have missed the symbol here. It is 7.5 volt. Now with respect to 2Iy, the formula is again same. It is 2Iy into I1. Rather it is precise to say that it is 7.5 minus 7.5 into I1. But is this formula correct? Right? So this is correct. It is correct because the current I1 is still hitting positive, and hence it is still correct. Now again apply KCL at V1. We get I is equal to Ix plus I1. We've already calculated I and we've already calculated Ix. So it's easy to find I1 as 14.25 amperes. Now when you substitute that, you get the answer as minus 106.875 watt. Again, this is also being your active element. Right. So now let's move on and see how do we give connection in your PSpice. Before that, let us see what all components are required. The components required are, you can see we have one VDC, that is one 12 volt, and we have one H parameter. Not H parameter, the part name is H for this voltage source depending on current or current dependent voltage source. And we have 4 resistances. This is 4 ohm 1 ohm, 2 ohm and 4 ohm. And we need one common ground. So these are all the part names that are required. So let's move on to PSpice and build this circuit. So first let us take resistance. The part name is R. We need 4. So place them accordingly. This is for 2 ohms. Using control R you can rotate. This is for 4 ohms. This is for 1 ohm and this is for the other 4 ohms. And you can press escape button once you have done with your elements. Then we need one VDC. So VDC is the part name. VDC is the part name for 12 volt. So use control R to rotate and place accordingly. And the part name is H for your current dependent voltage source type H. place the part, press escape button, and we need common ground. EGND is the part name for the ground. Now we have got all the components. Press fit to page, and let us name them or value them. So this is 12 volt, this is 2 ohms and 4 ohm, 1 ohm, 4 ohm, and 2 is your gain. So by default the gain is 1. Replace this 1 to 2. Click on save attribute and OK. So let's see how do we connect this. The one within your circle is your source. The one outside, the one which is not encircled, that's your dependent parameter. So here, this is your source, whereas plus minus is your source, and this is your dependent parameter. Now let's see how do we connect. So from 4 ohm, it's connected to 12 volt battery, and 12 ohm negative, it's connected to 4 and 2, and from 2 it's connected to 1, and from this junction it's connected to negative, right? And from positive you can see it's connected to 12 ohm positive and one end of 4. So from positive it's connected to one end of 12 and 4, and then at the bottom all are connected, and also connect your ground terminal. Okay. Now how do we connect this arrow? Now as I told, 2 is already given as a gain. IY, where is IY in the circuit? IY in the circuit is flowing through this 4 ohms and it is going downwards. So this arrow, what you can see, this arrow down which is going downwards has to be synchronized to the current going through this 4 ohms. So current always has to be connected in series. So I delete the wire, right? I delete the wire and I connect this arrow mark which is going down here. How do I do that? So current which is going down has to go through this dependent source and then complete its path through 4 ohm. And now if you see the current, IY current going downwards, right? Yes, it matches this orientation and then it completes its paths through 4 ohm. So this is how one has to connect. Now this is one way of connection. Let me also do the other way of connection also. Now I can also delete this here. Now current which is traveling through this 4 ohm has to travel to this dependent parameter. Kindly observe how do we connect. Now current traveling downwards matches the orientation of this arrow and then reaches this junction, right? So either the first case or second case, both are true. Just double check that you have given gain as 2. Yes, you have given gain as 2. Now save your file. I am saving under experiment number 5. Now what we need to find, okay, now we have given circuit connections. Now to how do we simulate? Okay, so let us simulate to check your results. Now what we must find? We must find first Ix, I5 and Iz, but let us also check for Vx, Vy and Vz. So we have seen that in the given circuit V1, V2, V3 are -3, 4.5 and 15, -15. So this voltage probe that you can see, right, or you can go to marker, take mark voltage level, okay, and place it at the ends. This is for V1, this is for V2, and this is for V2, and this is for V3. Now, but how when you simulate, you want to see the answers if it's V1, V2, V3. So what you do, you label the wires, double click on the wire, and you can label it as V1, and you can label this, that is at 1 ohm, as V2, and at 4 ohm as V3. Now you can see, if you can see the circuit diagram over here, At this junction it is V1, at this junction it is V1, at this junction where you have 2 Iy 1 and 2, at here you have 2 Iy negative and 1 no, that is your V2, right? And then this is your V3 where you have 2 ohms, negative of 12 minus negative of 12, and other end is 4, that's your V3. That is how one has we have connected. Now let us try to simulate and check your answers for V1, V2 and V3. So go to setup analysis, click on transit. As this is an DC circuit, you do not worry about the time. Save your file and then click simulate button. So as you click your simulate button, let's compare our answers. So now here click on toggle cursor. Let's check for V1. So V1, your answer is -3. Right, I'm just clicking my left click button. You can also right click to check your answers. Yes. V2, left click and right click, it is 4.5. V3, left click as well as right click, you can see the answer as 15 volt. Thus we verified that our theoretical calculations and simulation both are ditto or same. Right? So now let us move on further to check what we have to find. The question is asked to find Ix, Iy and Iz. So let's see how do we find Ix, Iy and Iz. So let's delete the voltage markers as we must find the currents now. So click on the voltage markers and delete them. Now Ix, where is Ix going? Ix is going here, downwards direction. So take a current marker. Okay, you have to find the current going down. So place it at the top. And you can rename, we'll rename for Ix, Iy, Iz later. And then the second current Iy is going down here, so place it at the top. Iz is moving right, so place it at the left. Right? So let us rename this R4 as Ix. So it's very easy to see in your simulation window. And this R1 as Iz, and this R3 as Iy. Now why am I labeled only these parts? Because I am finding current through 4 ohm, and the part name is actually Ix now. In your simulation window, you can see as Ix, Iz and Iy. So let's simulate. Now let's check for Ix. Click on toggle cursor. Ix, you can see it is -750 milliamp or -0.75 amperes. Next, let us click on Iy. I'll click both left and right so that it's very easy to compare the answers for you. So -3.75, yes, we have got Iy as -3.75. Next Iz, again I would left click A1 cursor, you can see the answer in A1 cursor. As a right click, you can see the answer at A2, it is 9.75. Thus our theoretical calculations and practical simulated answers both are true. Now, what is next? What else we have to find? So we have to find power associated with 2, 12 and Iy. Right? How do we find? We have found out the power currents, and then we have found out the power. So let's see one by one. So let's start with 2 ohm. Let us first find the current 9.75, and then let us see what is the power. So current through 2 ohm. Which current is that? That is nothing but Iz. So let's delete the other current markers, and here I am finding the current through Iz is 2. So let us hit on simulation button. Click on toggle cursor. Yes, it is 9.75. The same current that we have got. Now, how do we find power? It is I square into R. So what you can do is to find I square into R, you can go on, as discussed earlier, you can go on to add trace. Okay, and which current are we finding? It is Iz, right? So click on Iz twice with multiplying symbol, that becomes I square, into what is the resistance? 2 ohm, right? And then you can say OK. So let's place a cursor and check. We are getting 190.125 watts. Right. So when we simulate it, we are also getting the same answer, 190.125 watt for 2 ohms. So like this one can verify your power. Next, so again let's go to your circuit. Now let us find current power associated with 12 volt. So let us move this cursor here. And where did we find the current, or how did we find current? We need to find current I. To 12 volt, remember we used this current I, right? So let me place it in that orientation. Now this is I have placed. Now voltage, you can see they mark here plus and minus, right? So what I'll do is I'll try to place the voltage marker also. There are two ways how you can do. I'll explain both, positive and negative, and then I'll simulate. Now we are getting voltage separate and current separate. Right, this is the formula for your voltage, and this is the formula for current. As you can see, I'm getting negative. So to find out power, what you can do is you can click on add trace and you can type the formula. Voltage across which one? V1. So V1 colon positive, comma V1 colon negative, right, into negative of IV1. So IV1 is here. Click on OK and click on the icon that you want to see, and you are getting the answer as 162. So you can see we are getting incorrect answer. So what you can do is you can just type the way that we have applied formula. So this is V1 colon positive, comma V1 colon negative. This has to be caps. Okay, this is your voltage, and then into negative of IV1. Okay, this is what is our formula, right? As you enter, let's check our answers. Now to make you understand, what I'll do is I'll delete the markers that I have placed. Now let me select a color. Let me say green color, and I'll take the current marker and I'll place towards the direction of I, and I'll place it in the direction of negative I. So the red color, you should get the answer as negative, and the green color you should get the same as this answer I, which is 13.5 amperes. So let's verify that first. Let us simulate and then check the answers. So you can see, as I told, red color. What is red color current? Red color is negative of that. You should get, let's go with the green color. So the green color is the same orientation of this I, moving from left to right, and that answer should be 13.5. So let's check with green color. Yes, I'll left click and right click. I'm getting 13.5. So the current in opposite direction should be negative, that is minus 13.5. Okay. So now what I'll do is I'll multiply for this current into the voltage, the same formula V1 colon positive, comma V1, we have to use caps lock, V1 colon negative, right? So you can see I'm getting the answer as minus 162.0. Okay, the value of I is negative. That is practically it is an active element. Thus, the value of current I, practically it is flowing in anti-clockwise in clockwise direction. That is minus 13.5. And the opposite we are getting as plus 13.5. So whatever actually you are getting, that way if you do, you will get the answer. Now, after that, what we have to do? Let's find the orientation of current and power associated with 2I by. Okay, so as told, we have to find the negative current. So first of all, what is the power? 106. So take your current marker. Let me select the current again, yellow color. The current where you have to place? To the positive. Okay, so and this is H1. So let me also take your voltage marker and place it at positive end. negative. So let me simulate. Now toggle cursor. So you can see this is your voltage minus 7.5. So we have written that here, and this is your current, that is minus 3.75. No, but we should get 14.25 as the current. Let us check. I will just place a current marker to show you, and here we are getting, after simulation, we are getting the answer as minus 3.75. Although I have placed the current marker correctly, still I am getting the value of I1. So to get the value of I1, what we have to do? So kindly observe, I will delete this wire, I will place an voltage source with 0 value, and then I will reconnect the wire. Okay. Now if I simulate, I should get 14.25 or minus 14. No, I get plus 14.25. Let me just save the file again, and let me place the current marker and check it again. So I place a current marker here, which is still the same. That is current going towards positive. You can see the current is still going positive, and the voltage is 0, so it will not affect electrically the circuit. Now let us check the result. Yes, we've got the current as 14.25. So let us multiply the now, since we have got the current, let us also place your voltage marker. It's easier in that way rather than typing the code. Now let me simulate. Now I'll just copy this current formula, and I will apply multiply symbol, and I'll paste here, and let us click on toggle cursor and check the answer. Yes, it is matching. It is 106.875. Right? So this is how one has to simulate and check your answers for theoretical and practical simulation. Thank you.